students, as we are continuing study of photosynthesis in higher plants, so their topic is photophosphorylation and photolysis of water, and that is under light reaction. Now this light reaction is known as photochemical phase. This light reaction is called as photochemical phase. That includes the dispersion of light, splitting of water, release of oxygen, and finally the formation of ATP and NADPH. So during this course of light reaction, light is trapped by photosynthetic pigments present in the thylakoids, granule thylakoids, and the photosynthetic pigments are organized into two discrete light harvesting complexes, photosystem 1 and photosystem 2. So you know that LHC, light harvesting complexes, are PS1 and PS2. So in the first photochemical phase, light reaction involves photophosphorylation and photolysis of water. So let's see this photophosphorylation, the first step. And photolysis of water. So there is a diagram which will show you this. So there is a LHC, and this LHC is when photons of light is falling on it, then it is acceptor is there, and then this acceptor undergoes oxidation and reduction, and then another LHC is there over here. This also, this type of diagram is there in your book, and finally it is accepted by NADP. So everywhere photons of light is falling. Now who are those LHCs? This is LHC, that is PS2, and this is PS1. You know what are this PS1 and PS2. PS1 is the light harvesting complex where it is absorbing the light in 700 nanometer, and this absorbs the light in 680 nanometer. So when these LHC PS2 absorb the light, then it emits one electron, and this electron is accepted by one acceptor, and this primary acceptor again undergo oxidation and reduction reaction, and finally NADP, this NADP is changing to NADP plus this H plus and plus changing to NADPH, that product is formed. Now to compensate the loss of electron in the PS2, PS1 is excited, that also emits the electron, but again it is accepted and lost by many compounds, that is oxidation and reduction reaction goes on, and finally this electron compensates the loss of E680. But during the transfer of the electron from one compound to another, there is formation of ATP from ADP. So ADP is changed to ATP. But now the question is, these LHCs having chlorophyll, they have lost the electrons, but what will compensate this loss? So their photolysis goes on. So that is, water molecule is broken down to 4H plus, 4E electron, and oxygen. This is the photolysis of water, where water molecule is split into hydrogen ions, that is protons, electrons, and oxygen. And oxygen is the byproduct of this photophosphorylation, and this type of photophosphorylation we say it is non-cyclic type, because this is also known as jet scheme. So there are two types of photophosphorylation. One is jet scheme, and we say this is non-cyclic type. And there is one more cyclic type, and cyclic type of photophosphorylation involves only PS1. Here PS1 will release the electron and it come back to this PS1 once again. P700 is involved. Cyclic photophosphorylation takes place in the stromal lamellae of the chloroplast. This happens because of the stromal lamellae does not possess enzyme NADP reductase, that is essential for reducing NADP plus to NADPH at PS2, and the oxidized electrons in the cyclic photophosphorylation does not pass on NADP plus, instead it gets back to the PS1. So this is both non-cyclic and cyclic photophosphorylation, but the non-cyclic is the efficient one because their ATP as well as NADPH2 chemical energy rich components are produced. Go through NCERT. Thank you.